Okay, so today we are going to deal with the projectile motion part 2, theoretical part 2, where we are going to deal with all those kind of crazy stuff of projectile motion, which is even shown in your classrooms. Like I have done some of it, but you didn't have a basic description of that. Okay, so let us start from first case. Like this is a case 2. Like already I discussed in first projectile motion theory that whenever we are throwing a particle up on the inclined plane, for that case we did. Okay, so previous video, like this particular case we did like projectile motion along the inclined plane when we were throwing the particle from the ground and the particle was going up on the inclined plane. Okay, this time it is a little bit different case. What we have done, like we have considered our mass, like our body over here, which is thrown with some initial velocity. Let's suppose it's like it is already showing this is y component, but let us call this is its initial velocity of the particle, right or not, so that it will be helpful for you to understand perfectly. Now if we consider it to be initial velocity of the particle, what we observe that it has two components, one basic components along the horizontal path, as we know perfectly. Like this is my horizontal component, and then there will be what, a particular vertical component along the vertical y-axis direction also. This is first normal component. Second component is what, one, like this is my inclined plane. Let's suppose this is your inclined plane over here. I'm drawing it like larger so that you can understand perfectly. So this is my inclined plane. One perpendicular I can even draw on the inclined plane, right or not. And with respect to that, what I will get, this is my perpendicular along the inclined on the inclined plane, and then there will be one particular velocity along the inclined plane. Please try to understand. So there are four components of velocity which I have drawn over here. What? Try to understand, guys. There are four components of velocity which we are going to draw over here based upon the different angles. So I'll try to see. I'll try to just show you over here. Like this is like this way. Okay, so this is one of the inclined plane. Okay, and here this is my initial velocity of the particle, right or not, which is something like making angle theta or whatever it is. Okay, so this is my horizontal. You can draw it over here. Are you guys able to understand me or not? So this is my horizontal, and for that I have a vertical. So this is normal cases, but try to see what we can have. We can have something perpendicular to the inclined plane or not. A normal I can even draw for the inclined plane, which will be perpendicular, right or not. So this green line shows what, that it is perpendicular on the inclined plane, and another particular axis I will get, which will be perfectly parallel to the inclined plane, got it or not. So this is what I have done. Now look over here. Let's suppose I'm calling that this angle is theta. What this angle is? Theta. Look over here. If you have, let's suppose the particular projectile is thrown with angle theta with the horizontal, and the inclined plane is making how much angle with the horizontal? Beta over here. So this angle is how much? Beta. So if you look over here, this angle will be also how much? Beta. Now look over here. This is the initial speed of the particle. When you see the initial speed, what is going to happen? This whole angle is theta plus beta. What? This whole angle, this bigger angle is theta plus beta. So here I will have component how much? U cos theta plus beta. Right or not? Is it clear or not? Is this clear? Okay. So this particular initial velocity is how much? This angle is theta plus beta. So therefore initial velocity along the inclined plane is how much? U cos theta plus beta. Now look over here. If it is u cos theta plus beta, this angle will be how much? U sine, this particular component will be u sine theta plus beta. Understood or not? So on the along the horizontal and along the line which is perpendicular to my inclined plane, I have the component of initial velocity u sine theta plus beta. Along the particular inclined plane, I have the initial velocity u cos theta plus beta. Got it or not? Now, apart from that, I have two more components. Now, this initial velocity is making angle theta with the horizontal. So here I will have u cos theta, and here I will have u sin theta. I know it is hard, little bit undigestible, but please try to understand. I have just resolved the components. Are you guys able to understand this? Yes or no? Guys, is it okay? Okay. Okay, so we have got our velocities u sine theta plus beta, and here we have u cos theta plus beta. Then we have velocity perpendicular to that particular, and that is u sine theta and u cos theta. Now look over here, what we are trying to calculate, that at what time this particular particle is hitting over here, means what is the total time of traveling for the particle. So for that total time of traveling, what should happen? Try to understand this displacement. Which displacement? The displacement. Try to understand, guys. This is very, very important. So if someone says how to calculate that time of traveling, what we used to do, we used to write y equation, means displacement along y axis, and then we used to make it to equal to 0. And this is what we are going to do over here. Means when the particle is traveling, try to see that you have to make what displacement 0, y displacement to be equal to 0. If you can do that, what will happen? Your total time of traveling will be calculated. So I'll just show you one thing. So let's suppose if I am throwing a particle from here to here, what we observe, that particle is thrown from the ground, it is falling vertically on the ground only. So what we observe, that this y displacement is equal to how much? 0. So here this y displacement will be not similar. What will happen? What is going to happen? If you check the lines which are perpendicular to the inclined plane, the lines which are perpendicular to the inclined plane, means particle is starting from here, it is hitting the inclined plane over here. So along this particular path, along the perpendicular direction of the inclined plane, what will happen? The displacement is 0. So remember that displacement, Varun, you are not going to understand anything in this. Displacement along the perpendicular to the inclined plane is how much? 0. Please be fast, guys. We have to do this very, very fast. Okay. So if displacement along the inclined plane is 0, so what I will write over here? Y means this particular. I am writing for this equation. Okay. So along this side, if you check along this side, what is your particular, like look over here. If I consider the displacement along this particular perpendicular line, I'll have to take the acceleration for that along this perpendicular line, and I'll have to also take the initial velocity along this perpendicular line. That is very, very important. So as we know that gravity is always acting downward, so for that gravity, what is going to happen? There will be again two components for that. What components? One, perpendicular. See, this is my original direction of gravity, right or not? This is my original direction of gravity. If this angle is beta, so I will have this angle also as beta. I have already shown in one of the videos. So this angle will be how much? This particular line will be equal to g cos beta, and this will be along the inclined plane, it will be how much? G sine beta. So look over here, this is what it is showing over here. Okay, so you have the gravity also along the perpendicular direction of inclined plane as g cos beta. So I'm writing that acceleration along the perpendicular is how much? G minus of g cos beta, and acceleration along the parallel to the inclined plane is equal to g sine beta. That is the most important conclusion. Initial velocity u along the perpendicular direction, it is equal to u. So look over here. This is my initial velocity along the perpendicular direction, which is equal to u sine theta plus beta. U sine theta plus beta, while u along the parallel direction, it is equal to u cos. Look over here. The initial velocity along the parallel of inclined plane, it is how much? It is equal to u cos theta plus beta. Right or not? Is unclear or not? Those who are not able to understand, please see, this particular concept is of JEE. Like today whole class, it is going to be kind of level, means it will have a kind of level over here. Okay, so please try to make it understand, because it is a kind of tough part. Okay, is it okay or not? Tell me yes or no. Ankit, clear hai na? Hey guys, is unclear or not? Okay. Yeah. So now look, if you are aware of acceleration, if you are aware of initial velocity of the particles, so you can calculate the time of flight. What was that formula? So displacement along y-axis, it is equal to how much? U is equal to, I'll write it over here in next page. So what is the equation? Y is equal to initial velocity into time t plus of half of AT square. This is going to happen. Now look over here. This initial velocity should be also in y direction. This acceleration should be also in y direction. So I'm considering the displacement of the particle along this y direction, it is equal to 0. So therefore, what I can write, if it is 0, it will be, what is the initial velocity along that particular direction? Initial velocity along this particular direction is, it is equal to this line, which is u sine theta plus beta. So u sine theta plus beta into time of flight minus of half. Here gravity is different. what is the particular gravity along this particular line? It is equal to g cos beta. So minus of g cos beta into time of flight t square. So therefore, what you got as time? Time is equal to 2u sine theta plus beta divided by g cos beta, and that is the total time of flight for the particle when it is traveling down the inclined plane. Got it or not? This is what total time of traveling for the particle when it is traveling down the inclined plane. Is I am clear or not? Tell me yes or no. Is it clear? Inchara, is it clear? Are you able to understand this?
Yes, sir.
Radha, okay. Afan, Asparsa, okay. Asparsa, is it clear or not?
Yes, sir.
Okay. Okay. Now look over here. Okay, Hitesh, can you hear me? Okay. Now look over here. So down the inclined plane, we have calculated the time of flight. But try to understand this particular particle over here. It is traveling this whole distance from here to here or not? From here to here, it is traveling some distance over here, and that we call it as range. Okay, this is called as what? Range of the particle. But to calculate that range, it is very hard. So what we will do, we'll first calculate this x displacement. We'll use this beta, and we can calculate this r. So how to calculate this x displacement? It is very simple. What is the formula of x? As you know that already, that along x direction, the velocity, the acceleration of particle is zero. The acceleration of particle is 0. You know that particularly along x direction, along this particular direction, what is the value of acceleration? It is equal to always 0. So displacement along x direction is given by direct simple formula u along x into time t. Now look over here, along the horizontal direction, what is your initial velocity? This is my initial velocity, which is equal to u cos theta, not u cos theta plus beta. So what is my initial velocity? X is equal to u cos theta into time of flight t. So time of flight is how much? U cos theta into 2u sine theta plus beta divided by g cos beta. Right or not? As you are aware of this x, now r is very easy to calculate. As I know, r is hypotenuse over this particular big triangle, and base is what? Base is my x. So I can write r is equal to what? R I can write it as x by cos beta. Right or not? So therefore range calculation is very easy. R is equal to how much? X by cos beta. Sorry, cos beta. So therefore here r is how much? U cos theta into 2u sine theta plus beta divided by what? It will become g cos square beta. Right or not? Now as I know that, I can write 2 cos theta sine theta plus beta in terms of sine a plus b sine plus sine a minus b. So I'll write that term also. Okay. So I take next page, or should I write over? Okay, I'm writing it over here. Please see that this is cos theta, this is sine a plus, means I'm considering this whole term as a, I'm considering over theta as b. So what is the formula for that? Remember that. I'm minimizing this. Okay. What is the formula? That 2 2 cos, or 2 cos A sine B is nothing but it is equal to sine A plus B plus sine A minus B. I think this is correct. Yes or no? 2 cos A sine B, it is equal to what? Sine A plus B plus sine A minus B. Is it correct or not? Guys, is it correct? Ankit? क्या है ना ये सब? Hello guys. Guys, is I'm audible or not? Uh, where you guys are? Huh? This is the formula. 2 cos A plus B is equal to sin A plus B plus sin. How I can do this? Sin A into cos B plus, it will be minus 100% it is. Okay then. So it is minus of sine A minus B. Minus sine A into sine B. Okay, look over here. If it is minus, I think it will not be minus. Look over here. If it is minus, what will happen? This is what sine A into cos B plus cos A into sine B. Now, if you apply plus sign over here, wait. Okay, so look over here. If I apply minus, so minus it will become what? Sine A into cos B minus of cos A into sine B. Okay, correct. This is correct. So if I want to have cos A into sine B, I need this. Or what we can do is directly, like we can just, what we can do is over here, if we take into consideration, okay, if you take into consideration, change these angles. Okay, if you take here as sine A into cos B, 2 sine A into cos B, you will have to write the formula sine A plus B plus of sine A minus B. This is correct. Okay. So now look over here. I am considering sine theta plus beta. What will 2 sine theta plus beta? Okay. Into cos theta. I can write this as what? Sine 2 theta plus beta plus of sine beta only. Yes or no? This will be my form. So therefore, what you get as the range form, it is equal to u square sine 2 theta plus beta. Okay, it is sine 2 theta plus beta plus of sine beta bracket close divided by g into cos square beta. So this is the whole form of range when you are throwing the particle down the inclined plane, making angle theta with the horizontal. Got it or not? It is easy. Again, what I have done, I have taken the initial velocity component, one perpendicular to the inclined plane, one parallel to the inclined plane. Then again, I have considered acceleration perpendicular to the inclined plane, parallel to the inclined plane. I have utilized the displacement of y. If I have applied the displacement of y, I got my time of flight, and then I got my range over here. Is it easy or not? Easy peasy? Yes or no? Guys, I know it is hard, but can you understand this or not? Tell me. Is this okay? Hello? It is. Is it okay or not? अरे भाई थोड़ा जल्दी बोला करो यार. So I think this is little bit tough, but you can try to solve it always. Means I am not saying that it is very easy or something like that. Okay, like okay, got it or not? So you try to always solve this kind of question. Okay, now I'm going to give you one question based upon this, and please try to do it. Harshita, you have joined late, but no problem. I have recorded this video. You please see from initial. Okay. So now look over here. There is one question. What it is saying? A man is standing on a hilltop, projects a stone horizontally with speed v naught. Okay, means man is throwing a particular ball with horizontal speed v naught as shown in the figure. Taking the coordinate system as given in the figure, find the coordinates of the point where the stone will hit the hill surface. Okay, means what is going to happen? This particular projectile is going to fall like this way. What you have to calculate? You have to calculate the x comma y coordinate of the particle over here. Go it or not? Do it first. Do this. Try to do this. दीप आप नीलमंगला क्रॉस कर चुके हैं. आपने नीलमंगला क्रॉस कर लिया है क्या? मैं बोल रहा आपने नीलमंगला क्रॉस कर लिया क्या? नीलमंगला आप गूगल पे चेक कीजिए. आप कैसे पूछिए. ओके 20 मिनट्स ओनली दिखा रहा है ना. ओके 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 ओके. ठीक है ठीक 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 है. Can you guys solve this? Okay, what you do, this is like 6:53. One problem has happened. I have to go and receive my tea, okay? Like she's coming in the night and she will be like little bit afraid. 1 minute. Just let me stop the recording.